Have you ever wondered if you could find an equation for a circle? We have looked this year already at equations whose graphs are lines. We have not yet looked at how to write the equation of a circle. So the easiest, most basic circle to start with is what we call the unit circle. By unit circle, I mean its radius is 1. So if you look here, I've marked this grid. 1 is out here and 2 is out here. So this is 1 and this is 2. And similarly, -1 and -2. So this circle has a radius of 1. It's centered at the origin. In order to find an equation to represent it, I'm just going to pick any point on the circle. And let's call it x, y. Well, let's think about what we know. I'm going to sketch in a triangle, and we know that this length right here is x, because that's the x coordinate, and this one right here is y. We also know that the radius of this circle is 1. Notice that that's a right triangle, and the hypotenuse is 1. So the Pythagorean theorem tells us that x squared plus y squared equals 1. Okay, so that is the equation of a unit circle centered at the origin. Now, if you think about this in terms of a function, it does not pass the vertical line test, so it's not a function. And in fact, if you wanted to graph it on your calculator, you'd have to solve it for y. So I'm going to do that now. So if I subtract x squared from each side, I get y squared equals 1 minus x squared. And then in order to get the variable y without the squared, I have to take the square root of both sides, and I get this function right here. Now, if you really know what you're doing in algebra, you'll realize that I've already made a slight error, but I don't want to tell you what it is yet. If you know, that's great. If not, it will come up on the next screen. Okay, so what I want to now do is actually graph this function and show you that I do indeed get the circle that you see drawn here. So on the next page, I have our calculator tool, and I'm going to graph the function. I know it's kind of small. I'm going to graph y equals, oops, I already have the y. I need the square root, which is written down here as sqrt. I want to take the square root of 1 minus x to the power of 2. That's what I got on the last screen. If you don't remember, I'll just flash back there. Y equals the square root of 1 minus x squared. There's the same equation written in a different format for this calculator tool. And now I'm going to draw the graph. Okay, you notice I do get a function, and it's only the top half of the circle. If you think about what we've studied with reflections, you might figure out that in order to get the bottom half of the circle, I need to introduce a negative in front of the square root of 1 minus x to the power of 2. So now I'm going to draw that one. And there you have it. The graph of a circle is actually two functions put together. That suggests what I did wrong on this page. When you take the square root of both sides of an equation, you're really supposed to introduce this symbol, plus or minus, because actually there's a positive square root and a negative square root. And this equation, when you write it in this version, you can see that it's not a function, because when you plug in a value for x, you actually get two answers for y, one that's positive and one that's negative. Okay, so there's our graph of the circle on the calculator tool. And here's your homework. Write the equation of a circle centered at the origin with the radius of 2, and then solve that for y so that you can draw it on your calculator or display it on your calculator by graphing two functions at once. Just a little hint to get you started on number 1. So think about how I got the equation for the unit circle, the one with radius of 1. I looked at the graph. This time the radius is 2. So here's a rough sketch of what that circle looks like. It goes around the origin. Okay, and then remember what I did was I just said pick some point, call it xy, and then consider the right triangle where you know each leg and you know the hypotenuse. And the same relationship is true for any point on the circle. That's how it allows you to get a general equation. Okay, see what you come up with, and we'll go over that tomorrow or Monday. Okay.